Assalamu alaikum, brothers and sisters. I hope you're doing well, inshallah. So this is a video I've been itching to make, and it's something about a very exciting discovery. I just haven't been able to get some time to make a video about it, but I'm just on a bit of a hike and I thought this is a great opportunity to discuss it. And it's about the exciting discovery of a piece of rock on the Martian surface by the Perseverance rover. And I'm sure a lot of you have seen lots of articles about this. Some really excellent articles and some really good educational videos, scientific videos, as well as a lot of AI slop out there nowadays, unfortunately. So I thought it'd be good just to create a small video on this and just to clarify the situation. From a science background myself, I thought it'd be good just to make a video to talk a bit through this discovery. So what is it? It's a piece of rock from the Martian surface picked up and extracted by the Perseverance rover. So, of course, as many of you are aware, Mars is a planet in our solar system, the fourth planet in our solar system. It's slightly further away from the sun than Earth, so it's the next planet down, which means, of course, it's a bit of a colder environment, especially with the fact that it doesn't really have a significant amount of atmosphere which would retain the heat. So it's a bit of a colder atmosphere in the minus temperatures. And there's been a lot of thought among scientists, especially astronomers, about whether there was a period in Mars's history where it was a bit more similar to Earth, where it did have a stronger atmosphere that could help retain heat to match kind of Earth temperatures, whether there was tectonic activity also occurring on a significant scale where, you know, the temperature was elevated. And the reason that this is such a big thing is because if there was similar environments to Earth back in Mars's history, that would have given the opportunity for liquid water to occur on Mars's surface. And of course, we know wherever we find liquid water on Earth, it's associated with life. So that would open the possibility of Mars having hosted life. So, what exactly is this discovery? So, with this in mind, a lot of scientists that have been working on the Perseverance rover. A little bit about Perseverance. Perseverance is the latest rover that's been sent to the Martian surface, and by extension, it has the most advanced tooling. So it's like a mini scientific laboratory on the Martian surface with the most advanced tooling of any rover that we've ever sent to Mars. And what does that mean? And that means it can just conduct much more detailed experiments than previous missions on the big questions we have about Mars. The biggest one, of course, being if life existed or does exist on Mars today. Of course, when you spend billions of pounds or billions of dollars on such an expensive rover, you want to make sure it goes to the right place. And there was a reason why Perseverance landed in the place it landed, and that was because it was selected by a host of scientists. Jezebel Crater, which is the location where Perseverance landed, was an ancient riverbed. Actually, it was more like an ancient opening of a riverbed. And interestingly, I am currently standing on the Earth's equivalent of Jezebel Crater. So this is like a riverbed. This is a river opening up into the sea. Whereas in Perseverance, this case, it's on a river mouth opening up to a lake bed. But yeah, it's pretty much the same thing. So you can see this is the kind of surface. Imagine this surface fossilizing and hardening over time, over billions of years, and then becoming solid rock. This is the kind of stuff Perseverance has been sampling and testing on the Martian surface. It's not just going to land in one place and take samples from there. It's been moving across Jezebel Crater, so taking samples from various points along the river mouth, about 27 samples across the river mouth and across the river, and the ancient river, of course, the dried up river. And yeah, it's been analyzing the data, trying to see what's what and what compounds are existing in these samples, and etc. And what's happened is it's come across a very interesting sample called Chevaya Falls. Now this sample, and I'll pull it up on the screen in a bit, it's got these very characteristic leopard spots, these kind of leopard spot shapes, as well as these little poppy seed black shapes, and scientists are extremely puzzled about what these could be initially when they came across it, because of the elements and compounds associated with the sample. Now this sample has been massively scaled up, so what you're seeing, these spots and poppy seeds, they're actually tiny millimeters, but nevertheless they are super interesting, because the fact is they have elements like iron, phosphorus and sulfur deposited in very interesting ways. So usually when we come across these elements, iron and sulfur especially, they're typically found in very high energy states, whereas what we're seeing here in the sample is iron and phosphorus being in these compounds and very low energy states, and that indicates there's been a process that has shifted these iron and sulfur elements in this material from a high energy state to a low energy state. Now of course, as we're all done chemistry to some degree at school, this could be done through heat, this could be done through chemical reactions, and it can also be done through life. So for example, on this riverbed, basically estuary riverbed we have here, we have microbes right now today that are bringing those iron and sulfur molecules from a high energy state to a low energy state. And of course, if you are sampling a location that is very similar to this, but it was very similar to this billions of years ago, and this sample has been hardened over billions of years and is indicating such processes, that's why it's a very interesting and very special sample, because it could be proof of life. But of course, with that situation, it's very important from a scientific perspective to be very close to certain before announcing such discoveries. Previously in history, we have had announcements pretty much to that level that we've discovered life. An example that comes to mind is President Bill Clinton. He made an announcement when scientists discovered a Martian rock on Antarctica surface, which had a microbe-looking feature, and he announced that it's looking like it's life, and eventually it turned out to be inconclusive or not biological at all. Also on Mars, we've had situations where the Viking lander mission, so these are the earliest missions landing to Mars from the United States, they felt like they'd done this experiment where they left out an edible sample in the Martian atmosphere, and they noticed there was gas being produced that would be typical of life, and everyone got really excited. They were announcing, oh, this is looking like it's going to be life, but eventually it was discovered that there's also, the surface of Mars is very different to the surface of Earth, and there's chemical reactions that could be occurring on the Martian surface to explain this that are not biological. So because of that, and because of the nature of science, scientists are very hesitant to announce that this sample in Jezebel Crater is life until they've eliminated all other possibilities. So what how can they eliminate possibilities? This sample was actually discovered a year ago, and there have been scientists that have been working on this for a year, trying to eliminate all the possibilities. And one thing that they've been looking at is this sample has two minerals, vivianite and gregite, and these are iron-based minerals that are often found in conjunction with microbial life being in that environment, so that's a very positive sign. But they're also produced from heat, and they can be produced through other ways, other chemical processes. The reason why that doesn't look the case here, and it looks like it's life that's producing these minerals, is because if they're produced, first of all, if they have to be produced through heat, that means that this sample on this ancient riverbed rock sample must have been exposed to high heats in around 150 to 200 degrees Celsius. And from all indications, it doesn't look like that was the case. It looked like it was like where I'm standing now, where it would have been liquid water flowing, so of course below 100 degrees Celsius. And yeah, it doesn't look like the case that it was in a hot environment. So therefore, it's not looking likely like heat could be a reason for this. Another reason is chemical reactions. So actually, there's small traces of olivine in the sample as well, and that also points towards life being the source for the production of the minerals vivianite and greigite, because olivine wouldn't be produced in such a hot chemical environment, but it would have comfortably been produced in a cooler environment. So it looks like all the evidence is pointing towards life, but we have to be a bit more certain before declaring it. So how can scientists go about conclusively, or as close to conclusively as possible, saying that this is life? The first thing is, I mentioned Perseverance earlier, is the most advanced scientific instrument that we've sent to the Martian surface. But of course, there's only a certain amount of scientific instrumentation and a certain level of instrumentation that you can send to Mars currently, because you need to take into account the fuel that's going to take to get there, the damage and the radiation on the way that might damage the equipment and tooling, etc, etc, etc. So yes, it's very advanced for the Martian surface, but in universities across the world, we've got far more advanced tooling than Perseverance Rover, because we are not restricted by the Martian environment and by the transportation it takes to get there. So of course, if we got way more sophisticated tooling on Earth right now, the natural explanation would be to get those samples from the Martian surface back to Earth. And that was actually what was envisioned by the US when they were sending across the Perseverance Rover. They made the Perseverance Rover specifically to pick up these samples, contain them, and then eventually they'll send a mission to retrieve the samples, bring them back to Earth, and then analyze them in the advanced laboratories we have on Earth today to provide more conclusive conclusions. Unfortunately, due to the current administration, the US administration making cuts to a lot of science through DOGE, for example, etc, etc, this sample retrieval mission has endured many setbacks, and unfortunately isn't looking to go ahead as soon as we had thought. And yeah, this has caused this was raised in the press conference when they were announcing this discovery, and yeah, it's very disappointing, you know, that general society doesn't value science. Even questions like this, which I'm sure the majority of the government doesn't value science as much as the general society does, because of course discovery of life on another planet would excite almost everyone. And unfortunately, the current US administration doesn't feel it's fit to spend a few billion when they spend billions and billions and trillions on wars. They can't afford to spend a few billion on just retrieving the sample and changing the history of Earth. But what's looking good is China are in a much better space for Martian surface exploration currently, because they have their own sample retrieval mission that they've been thinking about, and these samples on Jezebel Crater provide an excellent opportunity. They know exactly where to go now, and if they can pull this off in the next few years, which I think they're hoping to do, they're hoping to get a sample retrieval mission across to Mars and bring samples back to Earth. But if they do decide to go to Jezebel Crater and collect these Perseverance samples and bring them back, then we could be looking at a decision, like a more conclusive conclusion being made in the next decade, which is super exciting. And how can they go about making this conclusive decision on Earth based on Earth's laboratories? I can talk a little bit through that. So one way we already know that there are organic compounds in this sample. We already know there's iron, phosphorus, sulfur, olivine, greigite, and vivianite, and these are all indicators of potential life, but as I explained, could also be done through chemical processes and the like. One thing that does point towards life as well, which I haven't mentioned, is the way the sample is shaped. It does look like it's a process that's spreading in a way that a microbe would do with these chemicals. But yeah, back to the point. How can they test on Earth? How can they further test on Earth to point further towards it being life? And one way they can do that is by looking at carbon isotopes. Carbon exists in a variety of forms. So you have carbon 12 and carbon 13. So that means carbon with a certain amount of neutrons and carbon with a certain one more neutron than the other carbon particle. In life, you have life tends to prefer carbon, the lighter version of carbon. So if you take, like, this is gonna be a bit gross, but if you take like a square meter of me and you test the carbon within that, it's going to typically be carbon 12. Whereas if you take a square meter of any non-living object, it's going to have a higher amount of carbon 13 because of life's preference towards carbon 12. So if we get this sample back, if we get this Chevaya Falls sample back to Earth, and we test the minerals inside it, and we test the carbon inside it, and see that it's indicating a low amount of like carbon 12 rather than carbon 13, more amount of carbon 12 than carbon 13, then that would further push the evidence towards it being life. Another way you can test on Earth's laboratories whether this sample is life, is indicating of life or not, is looking at the chirality. So chirality is life amino acids, which I'm sure you're familiar with, especially if you go to the gym. Amino acids can be left-handed or right-handed, and life selects only one of those. So it's only only got one type of handedness on our planet. Whereas, you know, things can be. Oh, you can see a squirrel there. Yeah. Whereas amino acids can be left-handed and right-handed, but life just decides to choose one of them. So if we see a similar thing going on Mars, and it doesn't have to be the same handedness, if there's a preference towards left-handedness or right-handedness in the amino acids in this sample in Chevaya Falls sample, then that would be further pushing towards it being life. And of course, a third way that can also be done is looking at the organic compounds in there and determining their complexity. If there are very complex organic compounds, then of course that would indicate more towards it being life. And if they're more simple compounds, then, you know, it wouldn't indicate as strongly that way. So if China, for example, does bring those specimens back to Earth, and then we do test them in the laboratories on Earth, and then it's peer reviewed on Earth, and it does have a low amount of carbon 12, it has a specific handedness and chirality, and it's very complex organic compounds. In my opinion, I feel like the scientific community would then shift its approach and much more definitively start saying this is looking like it's life. And then it would have this kind of model that it follows, where they'll continuously look further and further to see if they can further and further confidently say it's life. But I mean, at that point, if it does tick all those three criteria that I mentioned, it's looking like you can pretty much say that it looks like it was life on Mars. And what is the outcome of that? That would basically mean that that we're not the only planet with life, and we weren't the only planet with life, because of course this would be fossilized life. So we're not saying that Mars, if it does come out that this was a living organism on the Martian surface, it doesn't mean that there's life on Mars today, because because the conditions on the Martian surface are way less suited to life than they would have been when this sample was, when this organism was living. But it does show that there's two planets where life has existed at some point. What would this mean? This would mean that, I'm just going to shift the light here because the sun's quite hot. This would mean that Mars had either a separate type of life that spawned completely independently from the one on Earth, or both Earth and Mars had a single origin of life, and due to potentially rocks from either planet's surface breaking off and hitting the other planet in the form of meteorites, then the other planet getting seeded with that life from the other planet. So what would this mean? This would mean that either Earth and Mars had separate spawning of life, and the life developed independently on Earth and Mars, or it would mean that one of these planets had life occur, and it seeded the other planet through a breaking off of its surface, which would hit the other planet as a form of a meteorite. Or a third option is neither Earth nor Mars spawned life. It was spawned in a different location, and both planets were seeded with that life. Now, I mean, all three of those is amazing, and all three of those would be super interesting. And we can't say anyway, and I think it would be very difficult, even after we discover that if we discover that this is life on Mars, this was life on Mars, I think it would still be very difficult to discover which of those three options was the true one. But for example, if it was that life originated on Mars and then shifted over to Earth, that would be very interesting scientifically, because the nature of Mars and the surface material of Mars, you can really easily access rocks 4 billion years old and beyond, whereas on Earth it's much harder to start to see fossils the further you go back in time. So maybe if we start exploring Mars further and further, we can start filling in some of the gaps earlier in the bacterial fossil record to start to see how things might have developed over time. Another thing is that if it was panspermia, I mean, this is panspermia basically when a planet or something seeds life into another area or another planet or another area location in the universe. If there was two planets that were seeded by a third location, then that opens the possibility of this third location also having life, of course, and then life being really abundant across the solar system. Regardless, any of these options, so if you had the first option where life spawned independently in both locations, Mars and Earth, then that would of course indicate that life is extremely widespread throughout the universe. If it was a second situation where life spawned in one location and then seeded the other, that would kind of not be as strong evidence that life is everywhere in the universe, but it'd still be extremely interesting, and we could look into the records if it was Mars seeding Earth, like I mentioned. But if it was a third situation where a third location seeded both these planets, then of course it's still interesting, very interesting. If it is the case that, you know, that it looks very easy for life to emerge and for life to be across our solar system at least, it raises the question why we're not seeing life when we look into the universe, and we look and observe much further into the universe, and we look across all the stars and galaxies, and we're not seeing much evidence for life. And this is known as the Fermi paradox, because Fermi paradox being, why are we not seeing indications of intelligent life across the universe if life is so easy to be formed? And of course, if life spawned independently in both Mars and Earth, that would exacerbate the situation. But yeah, I think I'll do another video on the Fermi paradox, because that's a whole different eggshell on its own. But yeah, I thought it would be very interesting to kind of do the video here, kind of really show you eyes on experience on what potentially would have looked very similar to the Martian surface a few billion years ago. And you know, it's amazing to think that potentially that Mars could have looked a lot like this. Of course, like the samples that we found, they're just microbial, so you wouldn't have seen any of this kind of green stuff from what we've discovered so far. But who knows, you know, if we carry on investigating the Martian surface, we could find potential multicellular life like plants and animals. But I highly doubt it, but we never know, Allahu Alam. And just to final point on this, and this is a very interesting thing, we originally were thinking life would, like potential signs of life and liquid water and all of this, would have been way earlier in Mars' lifetime, whereas the samples we found, they're quite late. They're a few billion years ago, so yeah, still very late, still very old, but much later than scientists thought life could have existed on Mars. So that's very interesting, you know. That basically widens the window for the period which scientists now think life could have existed on Mars. And of course, the longer you have life existing on Mars, the more likelihood there is potentially for multicellular life to develop. Yeah, it's amazing, interesting discovery. Another interesting discovery that you'll be hearing about soon is there's a moon around Saturn called Enceladus, and there's been a mission launched to kind of retrieve some samples from Enceladus. And the interesting thing about this is with Enceladus, you don't have to land the sample retriever, you just have to fly it past Enceladus, because Enceladus has these geysers which are like water jets that it's shooting out of its surface far into space. So what they're going to do is just kind of fly their rover through, fly their vehicle through the spray and then detect their molecules there. So keep your eyes peeled for that. I'll make a video on that inshallah soon when Discovery comes out in a few years. But yeah, nonetheless, this is an amazing discovery, the one on Mars, and yeah, massive implications for what it means to be human, for what it means to live in our universe. I'll catch you all later, inshallah. Assalamu alaikum.